kind of like general architecture is pretty simple. It basically consists of classes. And we have two types of classes in Projen: projects and components. And so in a sense, when you're in a sense, the project is kind of like the entry point for a Projen execution. And so when you execute a Projen program, it basically creates a project type and then calls a synth operation on the project type. And so we can start with that. So that's basically the project hierarchy. And then orthogonally, we have a bunch of classes we call components, which are generally composable and represent specific capabilities or specific tools. So for example, we have a component for ESLint, or a component that represents package JSON files, or a component that represents jest. And you can see them here, for example, a component that represents an ini file or git pod or whatever, toml files, TypeScript compiler. And so each one of those components represent basically a tool. You can think about it as a tool in programming for managing projects. And then we can compose these tools together into project types. And one of the things that we want to do with Projen in terms of like refactoring and like cleanup is we ideally want the project types to be just compositions of tools. And I'll talk about it a little later, but let's start with like the base class, which is project basically. It's like the absolute base class of the system, and then see what we have there. So basically project is like is the absolute base class. And so every project class in Projen always accepts project options, interface, structure, data type. And so the basic features of all Projen projects are, the project name. There's a concept of sub-projects, and we can talk about sub-projects maybe later, but I have to say that I'm not super fond of this concept. It's probably something we want to revisit at some point. There's an output directory, so you can like create a project and say, this is where I want the files generated by this project to be outputted. And by default, it's like the local current directory. Some logging configuration. And then there's basically support for specifying, this is actually new, support for specifying Progen RC file in JSON. And as you can see at the project level, this is kind of like the most ubiquitous format, right? Like it's basically the JSON format for project files. And then for every language that we support, we add support for specific languages. So for example, you can specify Progen RC in TypeScript or in JavaScript or in Java. I think that's all we support right now. Python is still not supported. I can share some details why. So, and then if we look at what's going on within the Projen constructor, it's not doing a lot. So it's basically just kind of like initializing the sub-project hierarchy, is resolving the output directory. And then the project at the base level, and again, that's an opinion that we can like discuss or talk about whether it's the right opinion or not, but it has a bunch of like basic common capabilities, again, for all Projen projects. One of them is, a git ignore file, a git attributes file, tasks and dependencies. And then this is the Projen RC JSON file. So let's talk about these four first. Git attributes and ignore file are all familiar, I think familiar to most people. Git attributes is like this way in Git to add attributes to files, and GitHub itself is using it to mark files as generated files, so that when you actually do a PR in GitHub, you'll see those files collapsed in the diff, so they're not cluttering your diffs. And ignore file is like the git ignore file, and this is, for example, a component. And you can see the components are always initialized with the project type as the first parameter. And if you think about it, it's kind of like constructs. CDK constructs are always instantiated within the scope of another construct. And so in that case, the base construct or the app is the project, and then the components are those. And we can, and you can see that, this component has some API, right? So I can like go into here and there's a bunch of like capabilities that, I don't know. Let me compile this for a second. And in the meantime, you can, and so ignore file is basically has some API for like managing ignore files. You can see I can like exclude stuff and include stuff, and we can like go a little bit into like how files are managed generally, because that's another foundational piece. And then there's a bunch of two kind of generic or common facilities. One is tasks and one is dependencies. Tasks is an object model that represents workflow activities. So all the tasks that you have to interact with your project. So you can like compile it or build it or run tests or release or bump versions. And so tasks are kind of like this foundational piece in Projen, and projects basically create and update tasks and, append other tasks to existing tasks. And the interesting thing about tasks, you can think about it as a meta model. It actually has an execution engine that's part of Projen today, but it doesn't have to be part of Projen. We actually have a PR. Chris had started working on a PR that migrates the execution engine of tasks to use makefiles. And it's an important distinction, right? Like in a sense, Projen as a general, philosophy runs when you run Projen synth, right? Like when you actually run your Projen program, and it produces files. And then there's a runtime step, right? Phase, where you actually run your build, for example. So you do, yarn build, for example, or you run build on your Java program, or and then the question is like, who's executing the commands to actually run the build? And I've made a decision to create an simple tasks execution engine as part of Projen. I'm not sure that that's the right decision. I think like that's debatable whether it's the right decision or not. And so you can think about tasks more of like as an abstract model that represents the activities that that need to happen when you're executing commands. And then the execution engine can be something else, right? It could be makefiles, it could be some other engine, it could be a workflow, it could be like a CI workflow. And so the model is pretty simple. And we can dive a little deeper into like how it's implemented, but it's but in a sense, when you're synthesizing your project, it creates a Projen tasks file here, this JSON file, and this is the model. So basically, if you're execute the runtime component looks at this file and uses that to actually determine what commands, you can think about it as like a big make file, for example. Does that make any sense? No response. I hope it does.
Yeah.
Okay.
Yes, it does.
Okay, cool. And again, I think like it's definitely an interesting conversation of what role does Projen take at runtime, especially if we're looking into Projen ejection. So you could like literally say, I don't want Projen after I've created the project, or at some point I want to get Projen out of the way. And so at this point in time, when you're taking Projen out of the way, it'll work, but you will still need Projen itself as a task execution engine, because these tasks are only parsable by the Projen execution engine, which is not necessarily the same component. Like we could separate those into two different things. Dependencies
you mentioned there was a PR to implement this as makefile or something. So you would basically end up with a makefile that executes the tasks.
Yeah.
Okay.
Basically, we basically take the same model and synthesize a makefile from it.
Right.
that represents the same relationships and dependencies between the tasks and things like that. And in a sense, it's actually the right, in a sense, I would say that that's actually the right kind of ubiquitous execution engine, right? It's available on every system, and so I like that direction. I feel like that's actually a healthy direction to go to. And again, since we're synthesizing these files, the sky's the limit in terms of what we can do there, right? Like, I mean, makefiles are a very robust building block, and so once you're generating them, and that's actually a pretty common pattern in build systems to generate makefiles. So I think like that's probably the right direction to go. Dependencies are another meta model that represents the project's dependencies, because there's some assumption, and again, we could debate that assumption, that every software project has the concept of dependencies, no matter what language you're using, no matter what, there's always a concept of dependencies. And this has some kind of a generic model for dependencies. So you can like specify the dependency versions using semantic versioning, and you can specify what role the dependency plays, whether it's a tool dependency, a build dependency, or a runtime dependency. And for example, this model is used to synthesize Node.js dependencies, and it's also used to synthesize Maven dependencies in Java from the same base model. And the nice thing about putting this at the base level is that we can actually reason about dependencies in an abstract way without like caring which language we're using, which is a pretty powerful concept. Again, these are all little explorations. I think some of them are going to go a long way. Some of them are going to fall apart at some point. I think this one is pretty interesting. And one of the other interesting things about this is that it's also generating a deps.json file here. And you could think of like IDE support that's generic, right? Like that's not language specific, that allows me to manage my dependencies or to show, a visualization of my dependencies, regardless of what language I'm using. So once you're elevating that to like this abstract model, you have more abilities to create like unified tools for that cross different languages and offer a nice unified experience. So yeah, this is basically, before I go into this, the logger is not interesting. It's just a bunch of like logging functions. But before I go into like Projen RC file, I wanted to talk about files. And so files are components that are all they're all derived from this file base class, which is an abstract class. And files are very kind of foundational to Projen, naturally, because basically Projen is just a file generator, like that's kind of like the core of it. And so this file base class has some interesting common capabilities around files. For example, you can determine if you want this file to be committed to the repo or not committed to the repo, and that would influence how the file is expressed in git ignore, for example. If you say if it's committed, then it would be excluded from git ignore, and if you say it's not committed, it could be included in the git ignore. And there's a separate thing to specify whether it's updating git ignore, and then there's a flag that says whether the file can be is read-only or not. And by default, all generated files are read-only. So you can see that the default here is true. And then you can specify whether the file is an executable or not. So basically kind of like these common capabilities around files. And again, there's nothing super interesting here to look at. You can see that it's basically going and editing the git ignore file, the git ignore, or annotating it as a generated file. And you can see that there's an abstract method here called synthesize content, which is basically what derived classes need to implement in order to actually synthesize the content of the file. And this method synthesize is basically implemented from the component, and we'll see the component model in a second, but that's what the component is calling during project synthesis. And so what this does is basically just like writing the file, right? Like it calls synthesize content, and it's writing the file to the specified directory, relative to the output directory, et cetera, et cetera. There's another nuance here that's kind of worth talking about, is this resolving model, because in many cases in Projen, and that's actually not very different from other CDKs, you want lazy evaluation of data instead of needing to like explicitly get involved into the synthesis phase every time. You can just plug in a function instead of a value for every object that gets synthesized into files, and then the resolver will automatically call that function before it serializes the file. So it's kind of like this simple lazy evaluation model. And we may see some examples of it, but it basically allows you to say, okay, I want this to be evaluated only during synthesis, this value. So for example, let's say you have a file that contains an array of things, and then as you initialize this thing, you just say, I'll give you an example later. It might be easier to just look at it through an example. But this is when we're talking about resolution, and it's kind of borrowed from the CDK token system, which works in the same way. What else do we have here that's interesting? Okay, so as I said, files are foundational in a sense, to the extent that you can like go to the project and say .files, and it'll give you all the files that are part of the project. There's even a bunch of, and you see that I'll just go through this for quickly. You can go and discover all the components that are part of a project. So you can do some kind of dependency injection type stuff. You can like query the project and ask it, what components do you have, or do you have this specific component? And it's a very powerful mechanism, obviously also very abusable. And I think like that's an interesting. It's in a sense what the construct tree allows you to do in the CDK. It's this ability to reflect on the meta, on the type itself. There's a bunch of useful methods for like adding tasks or removing tasks, some sugar. There's this one that allows me to, this is basically the Projen escape hatch. Because if, for example, you end up with a situation that you end up with a file that doesn't contain exactly what you want, then you want to be able to pick up that file and modify it. And so this method and this method are both useful in order to do this. For example, you want to tweak something in a JSON file that's part of the project, then you go and say project.try find JSON file, you specify the file path, and you get a JSON file object that has API that allows you to add property overrides and kind of mutate it last minute before it gets synthesized. So this is the Projen escape hatching mechanism. And then there's this is try find object file, which is like the base class for all the object files. So like object file is a file that's serialized from a JavaScript object. So JSON, YAML, TOML, all the types of files, almost all the types of structured data in Projen are actually object files. And to that extent, they offer some like common capabilities, like for example, adding an override. So you can like actually say, okay, this is the path inside my file, and I can specify this value inside this path. This is a pretty primary reason we wanted the object file. So I think we covered the foundation, right? Because basically with projects and files, everything happens above that. Oh, one more thing that I wanted to show you. Let's go over this. Tips are going to be gone. Not interesting. Okay, so there's this process of synthesis. So let's see how synthesis works. I think that's an interesting thing to dive into a little bit. So this function synth is a function of every project. So, and as you know, when you look at project at Projen RC files, always the last line would be project.synth, right? Like it's okay, go and commit your in-memory representation of the project into files. So this is basically what goes and iterates and writes all the files. So let's see what it does here. So it calls a bunch of hooks. So we've got like a pre-synthesis hook that's a project level, which is empty by default, but project types can the project types that extend can override it. So it calls pre-synthesis, and then it goes and calls pre-synthesis in all the components of the project. So there's a hook at the component level that allows me to hook into the synthesis process. And then it goes into all the sub-projects and excludes their output directory from cleanup. And let's talk about cleanup in this now. And then it cleans up. And so cleanup is actually an important piece. What it does is basically needs to it deletes all the Projen generated files from the tree so that Projen creates a fresh copy of all the new files. And that's how we can rename files, delete files, because otherwise Projen doesn't have any knowledge of anything that it had created in the past that's not modeled in the current execution. And so that's actually a pretty important piece of how synthesis works. And it creates some weirdnesses and the way it identifies Projen generated files is using a Projen marker, what we call, and that's basically kind of like a string, and you can see it, I think, at the file base level somewhere. Let's see. File base. Yeah, it's this string here. It says generated by Projen. And for example, you can see that anything that has this string will get deleted when you clean up the project. So we had this bug where this TypeScript file was deleted in the Projen project because it had this string. So we had to like split it into two strings, so it's not really matching that search expression. So it's a very rudimentary system. But it works, and it's actually pretty robust. It's not very different from how Kubernetes updates work. Kubernetes has a similar model where you can, when you can basically apply a change to the Kubernetes system, and you tell it to delete everything that has some tag, and that tag represents this marker, right? Like it basically goes off and like deletes everything, and then creates the stuff that's the new stuff. We could think of like a different model for this if there are some issues with it. One of the issues with it is like that Projen kind of needs to control the subtree. And so if you have multiple, for example, if you want to use Projen multiple times in a repo, you can't have Projen again, and you're not modeling it as sub projects, which again I can go into a little later. Then you have to put them side by side, because otherwise the root project will delete the files from the sub projects as it synthesizes itself. So you have to like put them as siblings instead of like as a tree. Okay, so after we clean up, we basically go and synthesize all the sub projects. So that's basically sub project support. It's kind of like this recursive synthesis, and then we synthesize all components. And then we call post-synthesis. So we call post-synthesis on components and post-synthesis at the project level. And that's it. This is basically synthesis, the synthesis process. And if we go into, we haven't, let's see if there's anything interesting here to talk about. Add component, yeah, this is basically project. And so maybe one more thing to show at the kind of foundational level is component. And you can see component is like dead simple, right? It's basically registering itself on the project, so we can have this discoverability model, and then it has these hooks. And by the way, one of the things I want to do, and there's a reason why I haven't done it yet, but one of the things I want to do is I actually want to derive component from construct. base construct base class. And that means that this will not be required, and it means that we get some other facilities from the construct tree that we kind of had to re-implement here. And also it means that we can actually use constructs inside Projen projects and components, and there's some interesting use cases that derive from that. But again, it's not critical to understand the.
So did,
So I
did
think
you did you consider like building up a little, database or something of the files that were generated, or maybe the file path and the hash or something, so you could kind of tell not only what you needed to delete, but whether they've been tampered with or edited in any way? Would that be useful at all, or is that not really important?
I didn't really need that. I think like this kind of like removal and creation process is stateless, right? And it keeps things really tight. And an important component of how Projen works is this anti-temper idea. And so again, the files that are generated by Projen are generated as read-only in most cases, or I think in all cases. So that's one thing, right? Like if a file is read-only and the developer's deliberately editing it, then it's actually, it's an intentional thing in a way. But additionally, what Projen is doing in all of the build workflows and release workflows, it adds a simple git diff command with the -- exit code switch, which means that if there is a diff after build, the workflow will fail. So it basically ensures that if something had mutated the source code during build, whether it's Projen synthesized a file that's different, or a test snapshot was changed, or something was changed in your source code as you were building, which is not supposed to happen, then the build will fail. And so this little trick is kind of like a safeguard against unintentional changes or unintentional situation where you change your Projen file and you haven't actually executed and updated your generated files. So that's
Cool.
I think like that's an important piece of like the story. And then there's basically another evolution of that piece in build workflows that are executed against your repository, not against Fort repositories because of security reasons, but build workflows that execute against your repository, so within your team for that matter. If there is a mutation during build, it'll actually push that mutation to your branch. And so we get this really nice developer experience where you could literally go to GitHub, modify Projen RC, which would likely cause some changes into other files, and submit a pull request with that modification. And the build workflow will automatically update automatically push any changes to your build, to your branch, so that your pull request will show all the changes. So so we get this like nice combination of anti-temper in the release builds with automatic mutation in the pull request builds, which is super useful and super kind of convenient.
You mentioned, sorry, were you finished or?
No. Yeah, I have.
Yeah, you mentioned all the generated files are marked read only, but what if you're about generating sample files?
Good question. So yeah, there's a simple support for generating sample files. You can see a sample file component here, and you basically see that it uses a write once file content. So it's basically if the file doesn't exist, it'll write it as read write, and that's it. Next time it won't change it, won't touch it. So there's like this one-off pattern for sample file, and there's also a sample directory. So you can basically say sample directory, and you can basically specify a bunch of files with contents, or you can even specify a source directory in your. You can say, I can put files in my as a kind of like a template, And then again, they're all gonna be generated once if if the source directory doesn't exist. And so that's useful for bootstrapping projects, right? Like when we're running Projen new, then for example, if you want to generate some source files under src, then you can say, okay, src sample directory src, and you can put some contents in there, and that content would be generated once and won't get, it won't be managed by Projen from that point forward. Okay, so this is kind of like the base level. Now there's a pretty rich set of components and a pretty rich set of project types. I don't think that we should go into all the details, but we can like walk through some of them to give you a sense of like how they're written. I think that, one of the things that's definitely something that we need to do is, you can see the source structure. There's a source src directory. All the tests are under tests. And then there's a bunch of subdirectories that represent submodules. And so if you look at the root index file, where is it? You'll see that these are the submodules. So these are exported as submodules. And so when they're imported by a user, you would have to be imported using this fully qualified name. And then there's a bunch of stuff here that's basically legacy stuff. Like ideally, we should start moving stuff from the root of the src directory into submodules, so that it's a bit more organized. Some of that here is like makes sense to be at the root, some of it not. And then there's another nuance between around these submodules, and one of the reasons we haven't done that yet is that in order to be able to publish this to Python and to Go specifically, these submodules can't have cyclic references between them. And so it actually requires a pretty major refactor in order to untangle some of the cyclic dependencies, because TypeScript supports cyclic dependencies inside the project. And so there's a bunch of kind of re-architecting some of the base classes actually. For example, project depends on file base, and file base depends on project. So they can't be in different submodules. They have to be in the same submodule. And so as you can imagine, there's a bit of spaghetti entangling here in order to organize this code a little better. But there's an attempt to like make this a bit more organized as this evolves. And so like you can see some of the more quote unquote modern source is organized a bit more like this. Okay, so let's talk about project types. I think like the most mature and advanced tree is the node, obviously the node project tree, because as you know, we use Projen mostly for stuff that we publish in the CDK team, and all the stuff that we use is all of the stuff that we do is based on Node. And so if I go to the Node project type, you can see this is the Node project, and it's currently derived from GitHub project, which you can see is already deprecated. And that's actually some kind of a legacy situation where we had not a lot, but we had some coupling at the base project level with GitHub capabilities, like workflows, for example. And I'm currently in the process of untangling that and extracting, as you saw, project is pretty pure at this point, but most of the project types, or all the project types, still have that coupling. And so the first step of like that decoupling was to separate project and GitHub project. You can see that GitHub project is even currently inside the project file, TS file. And so this is why Node project still extends GitHub project. And one of the interesting refactors that we want to do is we want to basically abstract away all the interfaces that these standard project types like Node project and all its derivatives have from GitHub. So for example, you'd be able to say, I want GitHub workflows to be my CI/CD system, or I want Jenkins, or I want Circle CI, right? And so that requires some abstraction that we don't have currently. So Node project currently is explicitly creating GitHub workflows, which is not what we want in the future, but we're in the process of like abstracting that away. It's not too hard. It's not really relying on like very, very specific GitHub workflows capabilities. It's just kind of like an evolution of this mess. And so that's why we have GitHub project, and GitHub project is not, there's not a lot here, but you can see some kind of components that are currently available to all project types that extend GitHub project. One of them is GitHub, Gitpod and Dev Container and VS Code and some random things, auto approve workflows, stale issues workflows, which automatically closes stale issues. And then there's basically the GitHub component itself, which has some support for GitHub capabilities like workflows, for example, GitHub workflows, or pull request templates, or dependabot. All those things are GitHub specific, or Mergifier. And so now when I dive into Node project, and again, there's a lot of stuff here that I feel that needs to be reorganized and refactored. As I said, one of my goals is to make projects just a composition of components, even declaratively, right? Like I want to get to the point where I can like define a project declaratively as a composition of components. And that's not the case right now. Like if you look at the constructor here, there's a bunch of stuff here. Some of it is in components, some of it is directly here. So there's definitely some work to be done to kind of abstract away some of those things. But maybe I'm trying to think what's the best way to walk through this, or maybe we don't have to walk through this. Let me see if there's interesting stuff here. Let's just do a quick rundown, and then if there's anything that you want to dive a little deeper into, then we can do that. So one thing that we did extract into a component is what we call node package, which is basically a component that manages package.json, which is actually one of the workhorses of Node project. And so this component takes care of like managing dependencies and managing all the stuff within package.json. And you can see here that it heavily uses these lazy tokens. So you can see, for example, the license field here is a lazy token that contains the contents of license. And then if license is not defined, then it contains unlicensed. And the reason for that is that there is probably not even needed as a as a lazy. I think like we had like an option to basically mutate. It usually happens when you want to allow people to mutate something after the project is created. So for example, if you want to have dependencies, if you want to support something like add dependency, then we can't serialize this right now. We need to like put a function here that serialize it lazily. So this is kind of like go ahead.
Yeah, if I wanted to mutate a file from a previous run of Progen, does it always regenerate the file from scratch?
Yes.
Or does it ever look at the file that it wants to mutate and then make a decision of what to change?
So generally, yeah, it would always generate the file from scratch using this cleanup model that I described earlier. However, we could do some other things. For example, the way node dependencies work is by mutating the existing file. So like, for example, node dependencies, when you're using dependencies in Projen, you're not specifying versions in the, right? Basically just specifying the dependency names. And the way it works is Projen would read the package.json file when it starts, capture the version numbers, and then when it generates the file again, it'll put the version numbers back. So this allows us, for example, to give tools like Dependabot or Yarn Upgrade or other external tools to manage versions of dependencies without having to like edit the Projen code, right? Like the Projen RC code. So it's not that it's impossible to mutate parts of files in a sense. You can think about it as like puncturing a little hole in the read-onlyness of the file, so it doesn't have to be like an atomic unit as a file, but it's generally speaking, it's much easier to handle it as an atomic unit. Does that answer your question?
Yeah, that was exactly the kind of scenarios I was wondering about.
Yeah. So we can walk through that scenario if you want to see the detail how it's implemented, but it's a bit hairy, as you can imagine. Okay, so this is basically kind of like the manifest, which is the package JSON itself, and you can see that it creates a JSON file component here with package JSON, and then the object is the manifest. So this is basically a mutable object, like the way these file classes work, these file components work, is that you give them an object, an in-memory pointer, and as long as you didn't call synthesize, you can modify the contents of this object as much as you want. So they're mutable in that sense, which is a nice model. It gives us the ability to, I can change things here, and those things will be reflected as this is. So this is another sort of laziness in how this works. And then there's a bunch of like heavy undifferentiated light lifting, I would say. So for example, auto discover binaries is a cute example. If you put a bin directory in your project and you have a bunch of executable files in it, see, it reads it and it adds them to your bin. It adds them to your bin field in package JSON. And then, for example, managing node engines is always a pain. There's a minimum version and a maximum version. You want the workflow to actually align to the node version, so it actually runs within the right version. And so it takes care of a bunch of like annoying heavy lifting or annoying undifferentiated lifting that you need to do. And then there's a bunch of methods that manage dependencies, and you can see that what it does is basically goes and updates the dependencies at the project level, at the model. That's the general model. And then when we're synthesizing, and let's see if we can find that code. Okay, so here we have render dependencies, which is basically the code that renders all the dependencies. And there's a bunch of logic in here to manage the dependencies. And there's a bunch different types of dependencies that's supported by package JSON. And so what it does is basically going and takes all the dependencies from the project. So it goes into the model and then starts to reason about them. So there's if it's a bundle dependencies, then do this, and if it's a peer dependency, then put it in their peer dependencies or runtime dependencies, and actually the model actually has a differentiation between test, development environment, and build, which is in Node. It's actually the same thing. It all goes into dev dependencies. So you can see a lossy transformation here between the model, which has more fidelity, and package JSON itself. And here's where it's reading package JSON file, and so it gets the existing stuff from package JSON, and it resolves them and kind of reconciles with the new stuff that was added. There's a bunch of like complexities around adding new dependencies. Go ahead.
Yeah, so this is what you were telling me about a few minutes ago.
Exactly. So yeah, here's basically pre-synthesized. I'm rendering the dependencies, and I'm actually storing them in some field, and then I think during synthesis there's resolve dependencies. Post synthesis we're resolving dependencies and writing a package JSON. And I think this can be also cleaned up a bunch, but there's two steps here. One is pre and one is post, because during synthesis there could be some changes to the dependency model. What else do we have here that's interesting? Yeah, this was stuff that we've seen. Okay, so this is sort of the node package. And so a node project basically creates a node package component that manages package JSON. And so everything that's related to the package is managed by this component. And then the other thing that the project is creating is tasks. And so, for example, what it does, there's a little thing here that it goes to the task system. There's a component that represents the task system, the task, all the tasks. And it adds an environment variable for all the tasks that add the node bin path to all the tasks. So when you're creating tasks in node packages, in node projects, you can just specify node tools, and the node bin path is automatically added. So that's kind of like how npx works, if you're familiar with that. And then it creates a bunch of like tasks, but it doesn't really add much stuff to it at the node project level, because node project is still not TypeScript. There's still no opinion about what type of node project this is, but it does create some kind of model for workflow. And I think that's actually one of the things that I'm interested in moving up to the base project level. I think the more we add to the base project, or to maybe one level down, but creating some kind of a common workflow across all languages, if that makes sense, right? I would and I can totally imagine such an abstraction, right? Because in all languages there's a build process, right? Like, and even if the build process is no op, right? If that's it's a language that doesn't need any compilation, but there's something that you run during your CI, your build workflows. So that's kind of like the build thing. That's what's producing the artifact from your project. And then there's a test. So I think that there is some interesting thing to be done around creating some base level tasks that all projects have to implement, because then it means, again, that we can like build common tooling that know exactly how to work with these projects, again, at the abstract level. They don't have to be to have specific interfacing for every different project type. But at this point, like the opinions start from the node project. So for example, if you go to Java project, there's a copy of that in a sense, right? Like there's also a build task and there's also a test test, but they're not the same object in memory, right? And so, but no project basically says, okay, there's a compile tasks, there's a task that compiles the tests, there's a task that runs tests, and you can see the tasks can also spawn other tasks. So for example, the task that runs tests will spawn the compilation task. And that's actually, a choice we did with the task system that is pragmatic, but I would say not ideal and probably can be enhanced. There's no dependencies between tasks. So there's no dependency model between tasks, which is definitely something that I would expect in such a system. But there is a containment relationship. So you can basically say my test task contains the test compile task. So whenever you run tests, it'll always run the test compilation, and then it'll run the actual tests. And it's more in line with like how node scripts work than how makefiles work, for example, or how build systems that have invalidation models work. And I've been toying with the idea of like adding an invalidation model to the task system. So you can basically say this depends on something and only execute that dependency if the output of some task had changed. And So it goes into this whole space of, creating runtime graphs and dependency invalidation. And again, we could do some really, really interesting things at the base level that will benefit all project types. So I think like there's definitely some area to explore in there. What else do we have here? Yeah, so this is the build tasks. It creates an ignore file for npm. So that's the file that basically manages what goes into the node module and what doesn't go, which is actually a very, very important file in node libraries. Many problems have occurred because of that. And so having that file automatically managed is really important. And then there's a bunch of workflow related stuff here. So you can see this is where the build workflow is created. And we can go deeper into that, but I guess we're running out of time. So do you want to let me see if I have some. What's your schedule like? I have some more time if you want to continue.
Yeah, I can go a little further.
Okay. So let's look at, there's tons of stuff, right? Like you can see there's tons of like components, and we can go go into the derived classes from Node. So there's TypeScript, and from TypeScript there's Jsi, and there's CDK libraries and CDK apps, and web. There's a bunch of hierarchy around web projects. So there's, like there's a React project, and so you can like see that the React project is a Node project, and so there's like tons of like directions to go to. Maybe one interesting one that we can like end with this session would be the release workflows. And the reason I like to show you that, because I think like a lot of the heavy lifting that Projen is doing is in that space of releasing software, because it's actually a territory that's not very well supported in most environments. Like and most environments support the building blocks and the kind of like the repository, the artifact repository, the package managers, blah blah blah. But actually managing the release, bumping versions, and managing changelog is a pretty involved thing. And so like Projen actually takes care of all of that in a really nice way in my mind.
Hey, Elad,
So let's
can I
just
just ask one unrelated question? And if it's too complicated for now, we'll just skip it. But I've never quite understood the relationship between Projen and Jsi. What is there one, or?
No, well, there is one. There is two, actually, two relationships. One is Projen itself is compiled with Jsi, so it could be used from every language, with the vision of being able to write your Projen RC file in the language that you're using. And the only currently supported one is Java, besides TypeScript. And so basically there's four formats for Projen RC files. One is JSON, one is JavaScript, which is the default, one is TypeScript, and one is Java right now. And the idea is that we should support all JSI languages. And it's actually a really nice experience. Like if you're creating a Java project with Projen, your Projen RC file is going to be in Java, and you can like use all of Projen's capabilities from Java. You don't have to like leave your IDE or go to learn JavaScript for that matter. And so that's one relationship Projen has with JSI. The other relationship is that there is support for JSI projects in Projen, right? Like as a project type. And so you could create projects that are JSI projects with Projen, and that's kind of like the source, the origin story for Projen was the JSI use case, because of the complexity around releases and publishing to multiple package managers, and so that's a lot of the heavy lifting that Projen is doing, right? It's basically managing
Okay, cool. Yeah, I knew about the second one, but I couldn't.
Okay.
First one was what I was struggling with. That
Yes.
makes sense.
So the first
Totally
one
makes
was
sense.
basically kind of like a foot in the door, so that we can use Projen from multiple from any programming language. I don't know that that's a very prevalent use case right now, but the vision is to enable that, and I think like that's one of the things, one of the lessons we had from the CDK. If we don't start from these constraints, it's impossible to like add them back. And
Right.
so making sure that Projen is compiled through JSI makes it kind of forces the API surface to be compatible, which is a nice trait. Okay, so let's see the release component. Just walk through the release component. I think like that's going to be the end of it. So I'm thinking, okay, let's just go through the options first, because I think like the options can cover some of the interesting features. Release every commit means, and that's actually the default behavior for Projen. And I think actually in my experience, a bit of a industry mind shift in a way, especially for libraries, where we're doing continuous releasing, right? And it comes from the CDK project itself, which is doing weekly releases, and making a release a non-event, right? Like, so basically Projen takes the approach that says trunk-based development. Every time you commit something to mainline, it's out there, it's public, it's released, it's generally available. Again, you can switch that off if you want, but the default mode for Projen is that mainline is production. Whether it's a library or whether it's an application, mainline is production. If you don't want to release from a change, you can like always create a branch, right? And Projen releases also support multiple branches, releasing from multiple branches, and we'll see that in a second. But the default mode is release every commit, which is extremely powerful, and it creates a really healthy development model in my mind. It's very opinionated, of course. Release schedule is if you actually want to trigger releases on a schedule, so you can release every week or every month or every day or every whatever. Artifacts directory, and that's actually a common, like one of the goals for this release component was that it's not tied to Node.js or to JavaScript in any way. Like it's actually a generic model for releasing. But the part of that model is that there's a directory where artifacts go after build, and so that's kind of like the default is this. And so the expectation is that the project will, when you run build, the build task, it'll produce the output. Eventually, it'll produce the output under the this directory. That's kind of like a convention, sort of a convention, but it's also expressed here. And then there's a bunch of
the
go ahead.
comment on that said will be published to NPM.
Yeah, that's actually not the true. I mean, published to package managers.
Okay.
You know. This is a hook that allows you to add some GitHub workflow steps. And so here's an example of like some coupling to GitHub workflows that we need to untangle. This is a container image that can be used for the workflow. Jsi Release version. So Jsi Release is an underlying tool that we use to publish to package managers. It's actually not tied to JSI. It was created as part of the JSI project, but it's actually not tied to JSI, and so you can like control the version. We should probably rename this project because it's confusing. Post-build steps. Here's the anti-temper stuff that we talked about earlier. So you see that by default it's true. And then you can specify the major version to release from the default branch. So you can say, I want to release version 1. So by default, the major version is not enforced. But if you actually specify major version, then you won't be able to make breaking changes without explicitly bumping the major version. It's actually a really powerful capability. And the release model, the bumping model is based on conventional commits, which is a standard for commit messages that allows us to identify what changes occurred between releases. produce the changelog and identify the type of bump, whether it's a patch bump, a minor bump, or a major bump. And so additionally, there's some protection against major bumps that are not intentional, which is an important important piece in like managing healthy semantic versioning story. And again, those things are, most projects just do them wrong. I think like that's a really good example of where Projen is like raising the bar dramatically on like quality of software delivery, which is one of the goals of the project. Pre-release is there's support for dash pre-release, dash beta, dash alpha, blah blah blah. Release workflow name, not interesting. And then there's a bunch of, and then you can actually specify a set of release branches. So you can say branch 2.x would release major version 2. Branch 3.x would release major version 3 with a pre-release tag beta. So you can like actually manage multiple major version branches, which we have in the CDK. All of those things are based on like real world use cases in the real world. They're used in the real world. And then this is a feature that basically opens up a GitHub issue every time a release was failed, so that it gets from, so you know about it. It's something that we added recently. And then other information the release component needs is the task that performs the build, basically. So this would be the build task of the project. So as I said, this is a generic thing, and so if you're in Node projects, this is the build task, but in Java projects, it's like the Java build task, right? It's a different task. So it basically gets a task that's executed inside the release workflow to produce the artifacts in the artifacts directory. And then there's a JSON file. It's a required field, right? Like it's not an option. This is just an example. But there's basically a requirement to have a .json file that contains the version, and then that's what's set after the bump. And so this is kind of like the interaction between the bumping system and the project. In node-based projects, this would be package.json. So basically, when we bump, we update the version field in the package.json so that the node build for whatever it is, or the node package, would include that version in the output, but that could be anything. And then branch is the default branch name to release from. So this could be main or whatever. And you can see all of those are required, right? Like, again, they're created by the project inside the project. And create a GitHub release for each release is basically a flag that says whether we want to also create a GitHub release. That's a GitHub release element. And then if we go into here, I don't think that we need to like dive into all of those details, but basically there's a component that manages the version, and then there's a component that's called publisher that manages publishing. And the interesting thing about so the publisher is where we've got, I can't even see it here, I think. Maybe. Never used this, but so it should be useful here. So you can see that this publisher actually supports publishing to all the package managers. So you can see publish to GitHub releases, package to NPM, publish to NuGet, publish to Maven, publish to PyPy. And what this publisher is doing is basically creating workflow jobs that are associated with the release workflows in order to publish to all the package managers. And when I'm saying release workflows, is because if you release for multiple branches, then we actually create a different release workflow for each branch that's triggered by a commit to that branch. And then we can add jobs to each one of the release workflows. Again, this is all implementation details. Eventually, as a user, you would just do, publish to NPM, and you specify publish to NuGet, and you specify the coordinates of the NuGet package or PyPy package or whatever. And it'll automatically create the workflow, create the jobs for the workflow, bind the secrets, blah, 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 all of this stuff. There's quite a lot of heavy lifting here related to the releases. And then this is the publisher. And then if we look at the bumping thing, the bumping logic, I think it's managed here in Yeah, it's managed inside version. And so this is basically what's managing the version of the project. And it's actually non-trivial, but what it does is it actually creates a bunch of tasks that are executed by the workflows. And one of the reasons we have this duality, or not duality, we have this model is that we have users who actually want to do manual releasing. They don't want workflows to perform releases for them. And so they're using these tasks manually. So they can say yarn bump, and then they get a new version, and then they do yarn publish to whatever, PyPy. So there's a kind of like this nice, because most of the actual logic for bumping and releases and implemented using tasks, the workflows in a sense are kind of just like wrappers around tasks. Which is one of the reasons I said it shouldn't be too hard to abstract away the workflow itself, because the workflow is just kind of like creating the environment for running the tasks. But basically, one of the things that you can see here, and that's another interesting choice, is that the bump task is using what we call a built-in. And basically a built-in is just some script, some node executable script that can be executed as part of a task. So it's just a fancy way to run some code in JavaScript during a task execution. And the reason it's needed is because doing things like bumping the version and working with the change log is more heavy lifting than just writing some commands and some bash commands, right? Which is basically the basic thing that you can do with tasks. So you can see here that release bump version corresponds to this file here, and this is basically kind of like a little program, and it has its code is actually here because we have some tests that run this, unit test that exercises to make sure that it works, because it's a pretty sensitive piece of the system. And so, for example, bumping requires listing the Git tags in your repository, sorting them in a specific way, finding the latest version based on the branch that you're currently at, right? So if you're releasing from the 2.0, 2.x branch or mainline, you would want to pick the right version. And then it'll use a tool called standard version in order to produce the change log. And then it'll create the change log, write it into wherever it needs to be written, etc. So there's a bunch of heavy lifting that's going on in the bumping process, and it's used by the release system. That's it. Is there anything specific? We can talk about new if we have some time, if that's interesting.
Could you say, so first, this was great. Thank you very much. Can you say a few words about what steps are involved in adding a target language?
Yes. So first of all, when you're saying target language, you mean a new project type, or you mean another language for Projen or C?
No, another project type.
Okay, so basically, sorry, go ahead.
No, that was it.
So basically, in order to create another project type, you just need to extend project or one of the projects, right? Once you did that, Projen is using the Jsi metadata in order to produce the new experience, the project creation experience. So everything is mostly automatic. Like you really don't have to do much in order to you don't need to explicitly register the project anywhere. It's basically reflecting on the type system, and every class that extends project either directly or indirectly will be represented in the list of project types. And then Alex, did you raise your hand?
Yeah, I wanted to sort of piggyback on that and ask you to talk about a little bit about why some projects are, here in sort of stored in Git and some are sort of external using.
You mean part of Projen or not part of Projen?
what's the difference there, and what's the roadmap, and sort of how does this relate to, adding new different types of projects?
So it's something that we should think about, right? Like the decision of whether a project type belongs in Projen or belongs into an external module. As you know, it's possible to create project types and use them from an external module. So in the sense that it's an open ecosystem, and we have customers, we have users who are, creating project types and publishing to NPM as libraries and then using them in Projen. So in technically, it's the same thing. There is some kind of a philosophical direction to make Projen batteries included, in a sense, so that it's easy to discover the wealth of project types and components. Obviously, it doesn't have to be only batteries included. Like it could be batteries included plus an ecosystem, and that's eventually the where we want to go. I think that eventually we will need some tenets to decide what goes into Projen and what doesn't, right? Like, and it kind of like intuitively the tenets are if the project type is a common language, is a common framework or a common environment that's widely used, then we would likely want to include it in the Projen project so that it's available out of the box for anyone to use. And if it's like something that's less common, then we can publish it externally, or we can like publish it externally initially and then move it into Projen if we want. And there's also some ideas around including external project types in the Projen new experience as automatically, right? Like I don't know if you've seen, there's some documentation, some ideas around kind of like registering external project types in the Projen repo, but not including the code in there. So basically saying, oh, there's a project type for I don't know, Next.js. Yeah, it's commonly used, but maybe it doesn't have to be part of Projen itself. We can just like register it so that when Projen produces its CLI, right? Basically, it's all about the CLI, right? It could go into that project, extract in metadata, and include it in the CLI experience. So you can like do Projen new Next.js, and it'll find that external project type. So we can get both worlds in a sense. It feels like battery is included, but it can also be managed externally. So it's definitely an area of exploration. To Mike's question, so again, projects. So let's see the Java project, for example. You see, it's a class that extends project indirectly here, but it extends project. There's an attribute called PJID, which is kind of like an alias for the project types, and it's used by new. So when you do Projen new Java, it'll find this project types. And I think if you don't, then it'll produce some ID for you, or I don't know if it's required. I can't recall if it's required or not, but and then all the options of the project are automatically discovered. So it basically looks at the type system, automatically discovers all the options, and produces the new experience for all the options. So if I do something like Projen new Java help, you see all these options here were automatically deduced from these options, data types and all their,
So it doesn't sound like you distinguish between a project type that's the project is in a new language versus any other kind of project type.
Correct. The only distinction is if we want to support Projen RC in that new language, which is a different.
That's a very different question.
Correct.
So there's nothing in this that would prevent me from generating a project where the Spark backend is in Scala and the front end
Absolutely
is in TypeScript because you are hardwired into specific language for the entire project. That's very nice.
Yeah, there's no opinion at the base levels, right? Like as you go down the hierarchy, you get more and more opinionated, obviously. And
Yeah, but that's just from my inheritance tree of project types.
exactly. And one of the reasons I want to extract most of the logic from the project tree into composable components is so you could actually pick and choose components to your liking, right? So you can say, oh, I want node package as a component, and so like now I have package JSON support, and I want Maven manifest component, and now I have, so this directory contains a node package, this directory contains a Maven manifest, and my project contains Java and Node together, right? So the more logic we extract into components, the more composable the system will be.
Very nice.